Hello, I am back with more questions, more Oxbridge style questions. This one is quite a nice one. Unlike the other questions I've done today, I have taken the time to actually fully attempt this one, so I believe I have a nice solution for it. So, let in be equal to the integral from 0 to 1 of x, or x to the n over the square root of x cubed plus 1. Show that 2n minus 1 in plus 2 times n minus 2 times in minus 3 is equal to 2 root 2, which is very interesting. This is going to be the first part. Show that. Um, Hence, otherwise evaluate I8. Now, this reminds me of a step question. The reason I chose this question in the first place, that reminded me of a step question I did. Is I think it's step three. Actually, after I'm finished with the question, I'll show you guys the question I'm talking about. So in the true Cambridge fashion, um, a question that's very similar to a step question. It's pretty much a classic. Although I don't think for an Oxford interview I'd expect something like this. But yeah, it's a nice question, and I'll explain why. My first intuition was integration by parts. However, this is quite an interesting integration of parts to do because um, usually when you have integration with parts, let's say uh, t sine t, you know that the t is going to be reduced to a constant, and hence you get something easy to integrate like sine, or cos in this case. But it's fine. It isn't quite like this. I kind of have to guess a function, and I think that the function that to guess it's pretty much what solves the question. And I'm currently waiting for my iPad to load, and I am getting quite angry because I've been having troubles doing so. Okay, so I'm gonna call it f of x, and I'm going to consider the following. Now notice how if I were to integrate x cubed plus 1 over minus a half, uh, I mean, my guess function would be x cubed plus 1 over half, because a half plus 1 is minus a half plus 1 is a half. I'm going to end up with an x squared in my numerator. Hence, I'm going to consider n minus 2. I'm going to borrow a power of 2 from my x to the n. And because I mean, this is just this, I can write it like this. So this is my guess function, and I'm going to differentiate it. When I do differentiate it, I'm going to use power rule. Something very interesting is going to happen. N minus 2, x to the n minus 2. This might be a bit tedious. I need to be careful not to make silly mistakes. Otherwise, not only is it going to be quite embarrassing, but also I'll be forced to do everything all over again. X n minus 2. And now this is going to be, I apologize for all those who don't like the way I am differentiating this, times 3 over 2x squared. And I really don't like the way I did this. Now this is going to simplify to, let's see if I can get the whole thing in, yes, f dash x n minus 2 plus 1 plus x n squared plus 1. Now I'm going to rearrange to make this the subject. Because notice that this is very close. This is actually the body of my integral. So I know I'm going somewhere with this. So I'm going to rearrange for this, and then I'll explain what I'm going to do. 3 over 2 xn, very bad square roots. Genuinely, you guys can't see this, but my iPad keeps on loading. I don't know if it's my Wi-Fi or something, and this is genuinely annoying me so much. Uh, and if it happens in my actual interview, because I believe they use Miro as well, I will genuinely crash out so much. I will cry in my interview. I don't care. I will cry. And, but until now, I have to kind of suck it up and appreciate the fact that not all drawings are perfect. Okay, now what I'm going to do is I'm going to integrate between 0 and 1. The reason I'm doing this is so I can get in. Well, if I integrate this from 0 and 1, we already know this is like integrating my my original function. Not integrating, just substituting 0, 1 into here. So that's nice. And then we have this. Now, because this is not the first time of me doing the question, and the first time I did it, I actually went down the path of integration by parts. And essentially, what we're doing is the same, but in a much smarter way because we start with this. This is kind of what you're going to get if you do integration by parts. So you know you're going into the right way. It's just what I'm doing now is slightly better, I believe. But yeah. So this is the same as 3 over 2 in is equal to 0, 1 xn minus 2 x cubed plus 1 n minus 2 integral x n minus 2. I think this step is going to be very important, and it took me a lot of time to get here, but you kind of have to write this like this. This is the same as my this is the same as this, so it's not going to change much. So if I rewrite this, I am going to get I'm going to evaluate this quickly. So this is 1 2 minus 0. I don't have to worry about that. And minus 2. Now, this is where the magic is going to happen. This is x n plus 1 plus x n minus 2. Is that correct? Yes. Over x3 plus 1 dx. Is that correct? No, this should be 3. Yes, this should be a 3. I missed it out. Okay, now it's going to work. Now we have this is very annoying. Whenever you guys see me going on my computer, it's because my iPad is giving me problems, and I don't have a touchpad touchpad for my computer, so it is much harder for me to do this. We can imagine now this, if you separate the two x's, you get this is going to be I, and this is going to be I n minus 3, which is kind of where it comes from. So we know we're going down the right path. This is the same as x to the n. And again, I don't know what it is with my iPad. It is genuinely very annoying. Plus 1 dx plus x n minus 3 plus 1 dx. Nice. Which is equal to in plus in minus 3. So I can finally rewrite this whole thing as, I'm going to go here, 3 over 2 in is equal to square root 2 minus n minus 2 of in plus in minus 3. And if you rearrange this a bit, you do get the following. This is, oh, those are nice too, considering I'm writing this on a stupid computer with my mouse. And if I'm gonna go up here, and in 3 minus 2, which is 1, so n plus 1. I believe the n plus 1 is also here. Oh no, it's 2n minus 1. Did I go wrong somewhere? I know this line has to be correct. This is also correct. It's quite annoying. I don't know what it is about Myro that keeps on giving me problems. I'm gonna do this very quickly. And I guess this, you can kind of see that this leads to this statement. Oh yes, okay, I get why. I'm actually going to be quite rigid with my working out. No, that's the wrong one. Oh, this is. Okay, I've got more space now. I apologize if this is quite the boring site, but I do believe it's worth it. Is this correct? Yes. And this should be the same as. I do believe you guys should watch this on full 1.5 speed. Quiet. Okay, nice. This was very nice. I guess the two hard parts of this question is realizing if you use by parts, finding the guess function, the correct one, and also this one is quite an unusual one. But even if you don't do it like the way I did it, you can kind of see that this is the same as that if you stare at it hard enough. But yeah, you can see how this is not intuitive at all. Now the next part, the I8, find the 8 value or whatever you call it of this iteration, and I'm going to use the formula we just derived. I'm going to start with 1, so I1 q minus 1 in plus 2 n minus 2 in minus 3 is equal to q root 2. How can I do this? If I plug in 8 here, I will get 16 minus 1, 15 I8 plus 2, 8 minus 2, 6 I. 8 minus 3 is going to be 5. So I guess my next thing is going to be having to work out what I5 is. If I put 5 in there, it's going to be 10 minus 1, 9. 5 minus 2, 3, 6, 2. And I2 is 4 minus 1, 3 plus 2 um, 0 in minus 3. We don't care about that because it's 0. So 3i q, and again I'm having problems with my iPad right as I'm about to finish. This is very annoying. This someone is doing this on purpose, and it's winding me up like crazy. It is pissing me off. You guys can't see this, but every like 5 seconds, my mirror like has to reload for some reason. I don't know. I don't think it's my Wi-Fi. I'm losing a lot of time because of this. Okay, it's back. Well, it's can't, it doesn't let me write. Okay, so I2 2 is 2 over 3. Okay, nice. I can now substitute that back in here. 9I5 is equal to 2 root 2 minus 6 times 2 over 3. Now this is 6 over 3 is 2. So I have minus 2 root 2 over 9. And I need to plug in into the original equation with I8 in it. So 15 I8 plus 12 minus 2 root 2 9 is equal to 2 root 2. Now this is equal to minus 12 minus minus plus 24 root 2 over 9. Just to check this is correct, so I'm bringing this on this side, so it does become positive. So I8 is equal to 18 plus 24 root 2 over. It's not letting me write. 15 times 9, which is equal to 18 plus 24 is 42 root 2 over 15 times 9. Okay, it is genuinely crazy how every time I record, something is wrong with my iPad. It's like I'm being prevented from doing this question. I am quite sure that's right. And this should simplify to 14 root 2 over 45. And that's my final answer. This one here. This was a very nice question. I really enjoyed it. But that's just to like show what was the step question I was referring to. It's actually this one here. It's very similar. I believe I do have a solution for this. It's very hard step question. Probably the hardest step question I've ever done. And let's say if this video gets, I don't know, the 10 likes, I'll probably do it. I'll probably do it anyways because I'm very proud of my solution. Even though I found out it's not exactly correct, but still, have a go at it. It's quite an interesting one. But yeah, I don't have anything else to say except for the fact that I am embarrassed at my inability to write properly, and I'm also ashamed of the state of technology nowadays. How are you telling me? I mean, there must be something intentional about the way technology misfunction. Why is it so targeted and purposeful towards me? Every time I record it, try to do something nice. Something wrong must happen. It is generally pissing me off. Um, but it's fine. I got through it. The question was fine. I was fine. I didn't make stupid mistakes. I don't know what I'm saying right now. I think I should just stop recording.